Question A asks us to draw the complete Lewis electron dot structures for CO2 and CO3 2-. So to draw the CO2 molecule, you have to count the number of electrons. Now C generally has 4 valence electrons and O generally has 6. So that'll add up to a total of 16 electrons. And in this diagram, you can see that there are 16 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16. And for the CO3 2-, I only drew one of the resonance structures because it didn't specify that I needed to draw all of them. So CO3 2- has a total of 24 electrons. And if you count these, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So those 24 valence electrons. And I drew the brackets around it to specify that it's a -2 charge. And then the second part asks us to explain why the bond length in CO3 2- is greater than the carbon-oxygen bond length in CO2. And as you can see in this diagram, the CO2 has double bonds, while the CO3 2- has 1 1/3 bonds. And to draw Lewis structures, we do like 1, 1, and 2, but in real life it would be like 1 1/3, like a partial one for each. So that's why I got 1/3, because 1/3. And as the strength of the bond goes up, the closer the molecules are together. And therefore, CO3 2- has a greater bond length because its bonds are weaker compared to CO2. And question B asks us to draw the complete Lewis electron dot structures for CF4 and SF4. So the total number of valence electrons in CF4 is 32. And if you count the electrons on this, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, they equal. And C cannot break the octet rule, so that's why it has 4 electrons bonded to it. On the other hand, the S can break the octet rule because if you look on the periodic table, the S has a missing d orbital, so it can accommodate for extra electrons. And SF4 would have 34 electrons, so all these F's account for the same, which would be 32. But you need to add but you need to add 1 lone pair to get that total number up to 34. And question 2 says to account for the fact that the CF4 molecule is nonpolar, whereas the SF4 molecule is polar in terms of molecular geometry. And the CF4 has a tetrahedral shape because it has 4 bonds and 0 lone pairs. So the bond dipoles cancel, so the molecule is nonpolar. However, the SF4 has a trigonal bipyramidal shape because it has 4 things bonded to the S and 1 lone pair. Therefore, the dipoles do not cancel, making the molecule polar.